All right, so in A, we showed that it was geometric by showing it was a multiplying pattern, and we divided 15 by 5 to find that R is 3, and then continued multiplying by 3 to check and make sure the pattern continued. In B, we're going to use the formula, U sub n equals U sub 0 times R to the n minus 1. So to find the ninth term is called U sub 9. We take the first term, 5, multiply by the d, which is 3, and we multiply 9 minus 1 times, so we do that 8 times. Does anybody have an answer yet? What'd you get, Gideon? Can anybody confirm that? 32,805? Good morning. So he's the only one who did the problem? Go ahead and check it. Oh, Sally confirms. Thank you. All right, 32,805. Good. All right. So you guys will remember we did financial word problems recently, but now we're going to do them in the IB way, okay? So that next year, you're going to have a very similar lesson if you take IB Math Apps, and you will not be confused by the wording or the way that they use formulas. They use some slightly different formulas. They are essentially the same. There's no different ways to calculate interest. It's just different ways to represent it. All right, so the value of a compound interest investment after n time periods is U sub n equals U sub 0 times 1 plus the interest rate to the n value. And we'll see how that plays out here. $5,000 is invested for 3 years at a 6% interest compounded annually. A, what will it amount to at the end of this period? So let's start with A. And we're going to be using this formula. So we need to know what is U sub 0. That's your initial investment. How much money was that? 5,000. Good. Okay. The interest at 6%, how do I write that as a decimal? It's 0.06. And n is the number of compounding periods. Now, it's compounded for 3 years, but only once a year. So since it's only once a year for 3 years, that's how many periods? Just 3 periods. But what if it was compounded monthly for 3 years? How many times would we have compounded it then? 36, yeah, because it would have been 12 times 3. So you'll remember that the formula we had used, it had the number of years and then times the number of times per year in the exponent. And in this one, we're just doing that automatically. So in this one, the number of periods is 3. We're going to use that. And now we're going to find how much it will amount to at the end of 3 years. So we're going to do U sub 3 equals U sub 0 times 1 plus 0.06. And that's going to be raised to the n, which is raised to the 3. Okay. Let's see how that looks on our calculator. If you did not grab a calculator yet, go grab a calculator. And if you're stuck on some mode like this one, what you want to do is just quit out of it. So you'll do second quit. And then you can clear. Anybody having trouble getting to a blank screen? Raise your hand if you need help getting to a blank screen. Okay. All right, so we're going to enter 5,000. Parentheses 1 plus 0.06. The parentheses are above the 8 and 9. And then to raise it to a power, you're going to use this button here. Raise it to the 3rd. Okay, so the caret button is here above the divide. Raise your hand if you need help finding a button. Okay. All right, so I'm getting 5,955. Can anybody confirm that?
Yeah.
Okay. Oh, that's interesting. On my answer key, I have it off by, because I put $500. It's $5,000 though, so. Yeah. You're right. My old eyes were seeing that as 00. It is 0.08. Yeah. So he's getting $5,955.08. Okay. $5,955.08. All right, and then it says how much interest has been earned. So if you started with 5,000 and you ended with $5,955.08, what do we do to find out how much of that is interest? Just subtract it, yeah. Good morning. All right, then you'll notice for the second problem that we are skipping to problem number 5. And the reason I skipped ahead is because this is one of the more interesting problems. And then I'm going to give you some of those in-between problems for your whiteboards. I'll take it. Thanks. All right, those of you who just came in, grab a calculator by the door. We're using these graphing calculators today.
Was I supposed to check in?
So those of you who just came in, we are using IB formulas and format today, and we're using the calculators because in an IB class, one would use a calculator and not Desmos. So we're just trying to get used to those things. I know not everybody is going to the same thing next year, but I did want to give people a chance at this. All right, so in example 5, Gray invested $4,000 in an account for 8 years at 4.2% interest compounded half yearly. Inflation over the period averaged 3% per year. Okay. In A, we're going to just calculate the value of the investment after 8 years. We're not going to worry about the inflation yet. Okay, the inflation comes in part B. So for A, we're still using the formula at the top here, this formula. And it's U sub n, but this time n is not the number of years, it's the number of compounding periods. Yes?
Do we need to know this for our final?
No.
Oh.
This is a preview instead of a review. Okay? So we need to find U sub n, and n is going to be the number of compounding periods. So if there are 8 years and you compound half yearly, how many compounding periods are there? 16. Yes, you're compounding your interest 16 times. So this is U sub 16. All right, then we have to put in the U sub 1. That's how much Gray invested. Sorry, U sub 0. That's how much Gray invested. And that goes here. 4,000. And then 1 plus I. Now, I is not the inflation. I is the interest at 4.2%, but I need to make that a decimal, so it's going to be what decimal? 0.042. All right, and that is raised to the n, which is the number of compounding periods, which we said is 16. I'm going to pause there for questions. All right, calculate the value of their investment after 8 years. So we need to put this into a calculator. So those of you who just grabbed your calculator, if you're on some weird screen, you can try second quit to get out of the weird screen. You can try clear if you just have numbers that you're trying to get rid of. 4,000 The parentheses are above the 8 and 9. 1 plus 0.042. And then to raise to a power, that's below the clear. It's above the divide. It's this one to the 16. Oh, you know what, guys? I made a mistake. Can I tell you the mistake I made? For the interest, when it is compounded, when the interest is compounded more than once a year, you have to divide it so that it's compounded half for that first half of the year and half for the second half of the year. If it were 12 times, you would divide the interest by 12. Because this is 2 times, you divide the interest by 2. So the interest actually should have been not, I'm going to write this over here, 4.042, but divided by 2. So the interest is 0.021, and so I need to make this look like 0.021. Because we're going to do half of it halfway through the year and half of it at the end of the year. So we're not actually going to give twice as much interest. Like, that would be a lot. We're just splitting up the interest so that we do half of it halfway through the year and half of it at the end of the year. Say that again. Oh, so yeah, so basically when I multiply the 8 by 2, right, that means now we're calculating it 16 times, but we don't actually want to give twice as much interest. So we also divide the interest by 2. So we multiply the periods by 2, we divide the interest by 2. And we should end up with very close to the same amount of interest as if we calculate it once a year, but it's not exactly the same. It actually does end up to be a little bit more. Just a little bit though, not twice as much. All right, so that is 1 plus 0.021 to the 16. So here's a fun thing. If you press second enter, you should be able to get back to the line you just typed, and you don't have to retype it. So you can put the 2-1 in there, okay? Anybody want to hear that again? Oh, sure isn't. But it was second enter, okay? Let's let it think for a sec. I'm gonna stop recording now. Okay. $5,577.91. All right, so I'm glad that we got to see that part where you divide it, okay? Because that's going to be important when you're going to your whiteboards in a minute. Now, this part B is something that your other problems will not have, so you don't have to do this part B again, but we are doing it this time because we're going to adjust for inflation. So that means that we're going to try to figure out how much money would we have had if we take out the inflation, like how much did we really increase our investment by? So the real value, that's part A. Real value would have been multiplied by 1 plus 0.03, the inflation, and that's raised to the 8th power. And that real value would have given us this end value that we just found, the $5,577.91. All right, so if we take out the inflation, what would we have started with? So we're going to calculate the this one divided by this one. Now remember that 1 plus 0.03 is really just 1.03, so you don't have to write 1 plus, you could just write 1.03 in here, divided by 1.03 to the 8. All right, so that one's going to cancel, and that's going to solve us for the real value. And then we're going to put this into the calculator. So if you want to take this answer that you just had and divide it, you can just hit divide. And notice it says answer. That means it's going to use your last answer. And you don't have to type it again. and I need parentheses, 1.03 to the 8th. Okay, so I'm getting that the real value would have been $4,403.26. Is that what it says? You get 0.257? Okay, so 26 cents. All right, so that's what we would have started with if we took out the inflation.